Welcome back friends. Welcome back to another video session from this channel. So in this video session we will be studying regarding the initiation phase of the transcription mechanism in case of prokaryotes. So what exactly happens during the initiation phase of the transcription mechanism? So likewise the replication and the translation mechanism, the entire process of transcription, it can be explained or it can be studied under three different phases, and these are nothing but what? Initiation phase, elongation phase and termination phase. Is it okay? So at first we will be studying regarding the initiation phase of the transcription mechanism followed by elongation phase and termination phase in detail. So what exactly happens during the initiation phase? As I have already mentioned you earlier, the specific RNA polymerase enzyme, it successfully recruits to the promoter region during the initiation phase. But the specific RNA polymerase enzyme itself, it is unable to recognize the promoter region. In order to recognize the promoter region, the specific RNA polymerase enzyme, it takes the advantage of a specific factor, and that specific factor, it is nothing but what? Sigma factor. So once when the RNA polymerase enzyme, when it remains in association with sigma factor, under such condition, RNA polymerase enzyme, it acquires higher affinity in order to recognize the promoter region. Is it okay? So for your better understanding, let me present it on the board. So let us assume it as the 5' end. And it is nothing but the 3' end. Is it okay? And here the complementarity of this particular strand, it relates in case of the other strand. So it is nothing but the 5' end. So within the double-stranded genomic sequence, in order to initiate the transcription mechanism, there is an availability of a specialized site, and that specific site is nothing but what? Promoter region. To the promoter region, RNA polymerase enzyme, by taking the advantage of sigma factor, it successfully recruits there. Is it clear? So let us assume it as the promoter region. Promoter region. Promoter region, right? So to the promoter region, the RNA polymerase enzyme, it successfully recruits here. So let us assume it as the RNA polymerase enzyme. RNA polymerase. So RNA polymerase, by taking the advantage of sigma factor, it successfully recruits to the promoter region. So once when the RNA polymerase enzyme, by taking the advantage of sigma factor, when it successfully recruits to the promoter region, now it leads to the formation of a specific complex, and that specific complex, it is nothing but what? Closed complex. Is it okay? So let me write it on the board. What it is? Closed complex. So once when the closed complex, when it successfully forms, now the specific promoter region which is in association with the RNA polymerase enzyme, it undergoes melting. So once when the promoter region, when it undergoes melting, under such condition, the specific RNA polymerase enzyme, it is capable to associate with the promoter region so accurately. So once when the RNA polymerase enzyme, when it is capable to associate with the promoter region so accurately, under such condition, the specific RNA polymerase enzyme, it is capable to unwind, or it is capable to separate the double-stranded genomic sequence. So once when the RNA polymerase enzyme, when it is capable to unwind, when it is capable to separate the double-stranded genomic sequence, under such condition, closed complex, it successfully converts into open complex. Is it okay? So let me write it on the board. So let me arrange the things first. Closed complex, it successfully converts into open complex. So let me write it here. So it is nothing but the 5' end, and it is nothing but the 3' end. And here it is nothing but the 3' end, and it is nothing but the 5' end. Is it okay? So to the specific open complex, the specific RNA polymerase enzyme, it remains in association. Is it okay? So let us we assume it as the RNA polymerase enzyme. RNA polymerase enzyme. So here in association with the RNA polymerase enzyme, the sigma factor is available here. Sigma factor. And here all these are the nucleotides, right? So this is nothing but what? Open complex formation. So once when the closed complex, when it successfully converts into open complex, the structure of the open complex, it resembles the shape of a bubble, and that specific bubble, it is nothing but what? Transcription bubble. So formation of transcription bubble, it indirectly suggests or it indirectly says that the specific transcription mechanism or the transcription process, it is ready to fight. Is it okay? So let me write it on the board. What it is? Transcription bubble. Transcription bubble. So once when the closed complex, when it successfully converts into open complex, under such condition, the specific sigma factor, which is in association with the RNA polymerase enzyme, it successfully discards from its consent site. Is it okay? So let us we assume it as the sigma factor. So once when the sigma factor, when it successfully discards from its consent site, under such condition, the RNA polymerase enzyme, which is in association with the promoter region, it has to overcome two different strategies. So what are the two different strategies here? The two different strategies, they are nothing but what? Incorporation of AT nucleotides, and the other one is strong promoter. Is it clear? So let me write it on the board. What are those? Incorporation of AT nucleotides. And the other one is strong promoter. So in most of the cases, in case of the nascent mRNA, the initiating nucleotide, it is nothing but what? AT. That means in case of the nascent mRNA, the specific nucleotide, it should remain as A, and in case of the template DNA, the specific nucleotide, it should remain as T. So it is one of the important strategy. And the other strategy, it is nothing but what? Strong promoter. When the specific promoter, when it is a strong promoter, under such condition, the RNA polymerase enzyme, it is capable to synthesize abundant mRNA. And once when the specific promoter, when it is a weak promoter, under such condition, the RNA polymerase enzyme, it is unable to synthesize abundant mRNA. Is it clear? Now once when the closed complex, when it successfully converts into open complex, now the RNA polymerase enzyme, it is ready to incorporate the RNTPs. But here I need to mention you one thing. In case of the replication mechanism, in case of the replication process, in order to incorporate the DNTPs, the DNA polymerase enzyme, it takes the advantage of a short oligonucleotide sequence, which is nothing but primer. But whereas in case of the transcription mechanism, in order to incorporate the RNTPs, the specific RNA polymerase enzyme, it won't take the advantage of primer. So without taking the advantage of primer, the specific RNA polymerase enzyme, it is capable to incorporate the RNTPs so accurately. Is it clear? So once when the RNA polymerase enzyme, it is ready to incorporate the RNTPs, under such condition, the specific RNA polymerase enzyme, it halts for a certain period of time. So why the specific RNA polymerase enzyme, it halts for a certain period of time? After incorporating 2 to 3 nucleotides, the specific RNA polymerase enzyme, it halts for a certain period of time. So for your better understanding, let me present it on the board. So let us assume these are the RNTPs, right? So after incorporating 2 to 3 RNTPs, the specific RNA polymerase enzyme, it halts for a certain period of time. So why the specific RNA polymerase enzyme, it halts for a certain period of time. So during that particular time, the RNA polymerase enzyme, it monitors the accurate base pairing in between the nascent mRNA and the template DNA. And this specific mechanism and this specific process, it is nothing but what? Abort-to initiation. Is it clear? So let me write it on the board. What it is? Abort-to initiation. Abort-to initiation. So after the abort-to initiation, now the specific RNA polymerase enzyme, it successfully proceeds in 3' to 5' orientation in order to incorporate the RNTPs in 5' to 3' orientation so accurately. So once when the RNA polymerase enzyme, when it is ready to incorporate the RNTPs so accurately in 5' to 3' orientation, under such condition, now it leads to the formation of a specific complex, and that specific complex is nothing but what? Ternary complex. Is it okay? So let me write it on the board. What it is? Ternary complex. Ternary complex. So it is nothing but what? Ternary complex. So formation of ternary complex, it indirectly suggests or it indirectly says that the initiation phase of the transcription mechanism in case of prokaryotes, it is successfully organized. So once when the initiation phase of the transcription mechanism, when it is successfully organized, within no time the elongation phase of the transcription mechanism, it comes into the picture. So which we are going to study, which we are going to learn in the next upcoming video session. So I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.